In this question, we want to find the shortest distance between these two lines that are defined parametrically. Notice that I did choose to use a different parameter S for the first line and T for the second line. You didn't really have to, but it does make it a lot easier to set up these formulas if you choose two different parameters because they are independent from each other. So we certainly don't want to use a T for the first one and T for the second one because we're going to set up equations between these expressions. We want different variables, or it kind of all goes haywire. So these two lines don't necessarily intersect. I don't know if they do or not, and I don't feel like finding out. It'll be a byproduct of what we do if they happen to. But we're going to go into this assumption that there are two lines in R3 that don't intersect, which does mean that unless they're running parallel to each other, there should be some place where they're actually closest to each other. So just kind of an example, if I have one line running like this and another line running like that, it's hard to see in R3, but they may have like some place like this where it's orthogonal to that one and orthogonal to that one. That top line might be like higher on some plane than the bottom one. And we're looking for like, what is this shortest distance here? So it's kind of hard to see and visualize, and we can do it using geometry from the previous sections, but it's just so much easier to do it with this formula. So that's what we're going to do. And so basically, the shortest distance between them is kind of like just solving, let's see where they're equal to each other and optimize that. So for the x's, what we're looking for is 1 plus s equal to 2 plus 3t. For y, we want s minus 1 equal to t minus 1. And for z, we want what we want, or the closest thing to s equals 3. And so we can just rewrite these into a nice, clean system of equations. S minus 3t equals 1. S minus t equals 0. And s equals 3. And so this is the equation 1, negative 3, 1, negative 1, 1, 0 times st is equal to 103. And so that's our a, our x, and our b. So this is a, this is the vector x, and this is the vector b. And so this is what we, if they intersected, we would be able to solve this, but we want the closest thing to intersection. So we're going to set up the least squares equation. And again, that becomes x hat instead of b. And sorry, x hat instead of x, b stays the vector. And so we should be able to just kind of plug it all in here. So my transpose of a is like this. Times x hat. I always want to draw the vectors. X hat, and then 1, 1, 1, negative 3, negative 1, 0, and then times the b vector, 1, 0, 3. And so we just want to be careful in working those out. So I should get 3, and I'm going to add those together, negative 4, and negative 4, and then that should be 10. X hat equals, that should be 4, and negative 3. And so basically we just want to go ahead and solve this system of equations. So I am trusting that we're able to solve this one. It does solve decently nicely. So when we solve this, we should get that our x hat equals 2.5. And so that's going to be the s and the t. So s is 2 and t is 0.5. And so that's going to tell us basically the points on the two lines that are going to be closest to each other. So that's going to be my point on the first line, which I'll call P1. So that should be 1 plus 2, 2 minus 1, and 2. So I get 3, 1, and 2. And my point 2 will be on the second line. So I'm just going to plug in 0.5 for t. So that's 2 plus 3 over 2. Half minus 1 and 3, which should be what, 7 over 2 and negative 0.5 and 3. And so the distance between them is going to be basically just whatever the length is between P1 and P2. And so I should get a half, -3/2, and 1. So that's going to be root of half squared plus 3/2 squared plus 1 squared. So root of 1/4 plus 9/4 plus 1 equals, should be root 14/4, or root 14/2 if you like. But yeah, so that is going to be the distance. So they don't intersect because there is some distance between them. And we found the 2 points that are closest to each other, and those points are root 14/4 apart.